So let's do another example problem with two batteries. So we have two batteries, and they make these real batteries, so they have internal resistance. And we're going to actually, instead of connecting them nose to tail, we're going to connect nose to nose and tail to tail. Okay, we got two batteries here. We got EMF1, EMF2, R1, and R2. Okay, so internal resistances. So let's say the EMF1 is going to be 17 volts. EMF2 is going to be 12 volts. Let's say that R1 is going to be 2.2 ohms and R2 is going to be equal to 1.3 ohms. And so I want to know what happens. What is the same as the last problem? What's the current here? What's the power supplied? What's the power dissipated? And so you look at it and say, well, we got to have a direction. Now, we're going to pick a direction. I'm going to arbitrarily say the current is going this way. Now, it doesn't really matter. If you pick the wrong direction, you just get minus signs and everything. Okay, so if current goes that way, this is negative, that's positive, this is negative, that's positive. So current always goes plus to minus and plus to minus. Okay, so that's the orientations here. And so we look at this and we say, okay, from the loop equation, then we know that E1, if I start here and then go around in that same direction clockwise, minus I R1 minus I R2 plus E2. No, it's not plus E2 because I'm going from plus to minus. So if I'm going around this way, then I'm going from plus to minus. Plus to minus is negative. I'm going negative. So that equals 0. So if I do some algebra on that, then what I have is that E1 minus E2 equals I R1 plus R2, or I equals E1 minus E2 over R1 plus R2. Notice the backwards battery provides a negative voltage right there. So this is 17 volts minus 12 volts divided by 2.2 ohms plus 1.3 ohms. So the current is 1.43 amps. So now we have the current. Now, what about power dissipated? There's power dissipated in each of the little internal resistors. So we have internal resistance R1, and we have internal resistance R2. So there's power dissipated in each one. So power dissipated. So I squared R. So the power in R1 is going to be I squared R1. The power in R2 is going to be I squared R2. Okay. Well, we've got those numbers right there. So if you plug in those numbers, then you get the power dissipated in R1 as 4.5 watts, and the power dissipated in R2, 2.7 watts. Okay, so the total power dissipated is 7.2 watts. Now, what about power supplied? So power supplied is I times V. So for E1, for the EMF1, the power supplied is going to be equal to 1.43 amps times 17 volts, okay? And that comes out to be 24.3 watts. Okay, now we already found out the power dissipated. The total power dissipated was 7.2 watts. So what gives? Well, let's look at E2. What's going on with E2? So we've got negative, positive, but we got current going the wrong way. So that means the current is going negatively through there. So that means this is going to be or another way of thinking of it, the voltage is negative with respect to the current. So that means the power is going to be 1.43 amps times a negative 12 volts. And so that turns out to be minus 17.2 watts. Negative power supply. What is negative power supplied? Well, what is negative power? Power is the rate of change of energy. So if negative energy supplied, what does that mean? It means the energy is going into the battery. We're charging the battery. By forcing the current backwards in the battery, we're charging it. Now that's why your car battery, 12-volt system, now actually it's a little bit over 12 volts if it's working right. Your alternator is closer to like 15 to 17 volts. And so that means that the alternator is providing electricity in the car that is in excess of the voltage of the battery. So it's actually shoving energy back, shoving current backwards to the battery, charging the battery. And so the battery stores energy. You turn on the car, you use the battery to get the car started, but then the alternator provides the power that keeps the car running and recharging the battery. You can actually disconnect the battery and drive without a battery as long as you've got a good alternator. Okay, so, all right, so if we did this right, though, then the power supplied, because the power dissipated is actually negative, it's energy going out of the system. So what should happen is 24.3 watts minus the supplied 17.2 watts minus the 7.2 watts that's dissipated should equal 0. Well, does it? Well, it equals a negative 0.1 watts. And so, yes, that balances within rounding error. So, once again, it goes within rounding error. If it had not been close, that means that something would have been wrong.